Good afternoon, everyone. So welcome to another week of Azure DIY. Today, we're fortunate enough to have the Microsoft Azure for Fast Track team presenting to us. So Jason is the Fast Track project manager and John is a Fast Track engineer. So they'll be speaking to us on from developer to architect, how do we design geo-distributed solutions in Azure PaaS? So we have our solution in Azure, but how do we make sure that we keep this application up as long as possible and that it's scalable and relatively future-proofed? So if this is your first time tuning into Azure DIY, we actually run these sessions weekly. So the Azure DIY series is designed as a zero to hero training session focused on different app modernization topics every week. So while this week we are focusing on how to go from developer to architect, next week we also have a session on how to use containers in PaaS app services. So feel free to register for any of these. To quickly cover off logistics, we do have a growing LinkedIn community. So this is definitely worth checking out, as this is where all of the session recordings will be available after the session. As a disclaimer, this week we won't be sharing the slides, we'll only be sharing the video recording. Throughout the session, please feel free to ask any questions in the Q&A chat, or even just share your experiences around these relevant stories. Would love to learn more about what you're going through in your different companies and environments. So, as a quick warm-up before I pass over to Jason and John, we'll have a little bit of a quiz. So what is the cloud term used to describe a lack of self-managed hosting infrastructure where machine resources are dynamically provisioned? Is this hostingless, infraless, serverless, or no server? So this is a pretty easy one to start us off with. Do we have any takers in the Q&A, Shri?
No, not yet. I'm waiting on the answers. Let's give a few seconds for people to pop in their answer. It's a very difficult question, isn't it? Do I give them some hint?
Yeah, I mean, I may as well just give them the answer because we have a couple of questions to go. So the answer to this one is actually serverless. So while you still are running servers under the hood, it still is in an Azure data center. The way I like to think of it is not necessarily that there aren't any servers, but just that we have to worry about servers less. You'll notice as well that I am repping the Azure Functions ASCII shirt. So if you're a regular user of Functions, you'll notice that the Azure Functions core tools does automatically display that Functions ASCII when you start up that command line. I believe they took this away sometime last month. If you are missing it, however, you can add in a variable now to display that ASCII logo. So the next
actually we did receive a few answers, but I think there is a time lag coming. So maybe we'll give 10 more seconds before we actually say the answers.
Okay, cool. So that one was serverless. So the next question is, Cosmos DB is a globally distributed database. Is this true or false? So while we are waiting for the answers to come in, I'll just explain a bit more about what we mean by globally distributed. So this is the ability to transparently replicate the data anywhere in the world to enable our globally distributed apps to work with a copy of the data that's as close to its end users as possible. So the idea is that you can add or remove regions associated with your account without having to stop, pause, or redeploy that service in any way. So you can elastically scale throughput and storage at any time on demand on a global around the world scale to ensure that that service is always on. So in the case of Cosmos DB, Shri, is this true or false?
So the first answer that I got was from Maksud, which was yes, and the rest are all, yep, all are true. So everyone knows it.
Yep, awesome, that's correct.
Yes.
Now, the last question before we hand over to Jason. So a zone redundant service refers to a service that is pinned to a specific zone Or does it replicate across zone as managed by Azure? Or does it synchronously replicate in one primary region, such as Australia East and Sydney, and asynchronously replicate to a secondary region, like Australia Southeast and Melbourne, and this is all managed by Azure? So this one is a bit of a trickier one. I know Jason is going to delve deeper into what this means and how availability zones work. So if this is a bit confusing, that's perfectly fine. Do we have any takers, Shrew?
Two. Someone has answered two. I've got one answer is C.
Yep. So the answer is actually B, that this replicates across zones as managed by Azure. So even if one zone in your availability zone goes down, you'll still be able to have that zonal redundancy that I'll let Jason describe more. So I will pass over to Jason and see you all on the Q&A.
Excellent. Thanks, Amanda. So I'll just get my fabulous deck here ready to go. So welcome everybody. As was introduced earlier, I'm Jason Purcell, and today we've also got John Downs with us. Both of us are from the Fast Track for Azure engineering team. In today's session, we're not going to be going deep into specific products or technologies, and this session is going to be more about talking about the architectural patterns and styles. All right, and I'll get my next slide happening. All right, just to kick off, I'll just very quickly cover Fast Track for Azure for those that haven't met us before or worked with our team. So yeah, Fast Track for Azure, we're a customer success program. We're actually part of Azure Engineering, and our whole reason for being is to help our customers move quickly and confidently into the Azure platform. We do that by providing tailored guidance from our engineers, leveraging proven practices and architecture guides that are out there. As you can see on this slide, we cover a broad range of topics, and the engineers in this region, we've got enough that can cover basically any aspect of the Azure platform. All right, my slide progress is now working. So today we're going to run the session in two parts. The first half, I will cover the Azure geographies, regions, availability zones, and reasons for why you may consider a geo-distributed architecture. And then John's going to get into more of the detail around the actual architectural patterns and practices. So I'd like to start by introducing something a little bit different to the usual Contoso, and we'll have a fictitious website called Fourth Coffee. So it's the place you can go for your coffee news, your cafe reviews, insider gossip on the coffee industry, and for them, the architecture of their solutions is something like this. So as you can see, it's a fairly typical modern web app topology. We've got a single page app backed by a set of APIs and functions and Cosmos DB there in the back end. So we'll come back to Fourth Coffee's solution shortly, but first let's have a little bit of a talk about the Azure geographical footprint. So Azure, it's a global service. We've got resources deployed all over the planet. Here you can see that we've got cloud regions in all of these locations. We've also got these things called edge sites, which are your points of entry into our network. We've also got one of the largest networks in the world. So for now, let's zoom in on Australia and have a look at how some of this works. In Australia, we've got 4 regions. Australia East is our biggest region. We've also got another one further south, Australia Southeast, and then 2 in Canberra, which are called Australia Central and Australia Central 2. So the 2 in Canberra, they're used predominantly by our government customers, but we do have other folks that like to leverage those regions also. There's another region coming in New Zealand, which a lot of folks are looking forward to. And for now, I'm going to zoom in on Melbourne, and we'll have a little bit of a look at the Australia Southeast region. So when we talk about deployments in Azure, you'll notice we mostly talk about regions and not particularly about data centers. So, of course, in a region, we're going to have data centers, and contrary to what you might have heard, many of our regions actually have multiple data centers. So in a region in Azure, a region in Azure is a geographical area that contains those data centers. So now we'll just head back up to Sydney and have a look at Australia East. So Australia East, that one's a little bit differently. It supports multiple things called availability zones. You might have heard about those being released in the recent past, and more of our regions are now starting to support availability zones. So, availability zones, these are distinct separate data centers or sets of data centers, and when we add an availability zone to a region, we deploy at least 3 of them. There we go. In each of these zones, that contain the data centers, they're also built far enough apart that they've got separate network power and cooling requirements and so on. So they're not dependent on the same infrastructure to keep the lights on, so to speak. So when we come to deploy our services into a region that's got availability zones, there's a couple of different deployment types that we might use depending on the service. So for example, if we're deploying a virtual machine, we'll decide which zone to deploy it into. So we'll throw this one into zone 3. It lives in its one zone. If we want to have redundancy, we'd need to deploy another VM in a different zone. And this is what is called zonal deployment. So there are other services that work a little bit differently. For example, we've got Service Bus. Service Bus is a messaging system in Azure. When you employ that using zones, what happens is, here we go, we actually spread the deployment across multiple zones. So, and then the data is actually striped across them with continuous synchronous replication. So I've got that going forward between zone 1 and zone 2 there. So that means that if one zone went offline, the other could still serve your solution. And this is called a zone redundant configuration. All right, so speed of light, something we can't forget about. Understanding availability zones and regions is key to designing a geographically distributed system in Azure. Depending on your business's requirements and risk tolerance, you could consider whether to use a multi-zone or multi-region deployment. Increasingly with our customers, we're seeing the use of multi-zone deployments where they can. And one of the reasons for this is that the speed of light is a factor with these kinds of architectures. It might be tempting to go and distribute your application across the planet and replicate your data everywhere, but pretty soon the latency involved in actually transiting the globe, that's going to become a big factor that inhibits your ability, your scalability and growth. So in this session, we're going to talk about how you can architect a geo-distributed solution to balance the various considerations and concerns and requirements that you might have. All right, reasons to consider geo-distribution. So it's worth talking about these reasons, why we might consider some form of geographical distribution of the architecture. There's many reasons why we see our customers come up with these kinds of architectures. Firstly, and yeah, very common conversations for us, it's around high availability and disaster recovery. These are both aimed at the same problem, keeping your systems up and running in an operational state, with the main difference being that HA is intended to handle problems while the system's still running, And DR, as it's in the name, it's intended to handle problems after a system fails. So in a multi-zone deployment, like the one we talked about earlier, it's often enough to satisfy these kind of requirements. But in each case, you need to have a clear set of requirements so you know what options you can consider and which ones you need to rule out. For example, one of the metrics that we talk about with all of our customers are recovery point objectives, or RPO. This is how much data you can potentially afford to lose if you absolutely had to due to a disaster. If you've got a really low RPO, then potentially a multi-region architecture isn't going to work for you, but John will run through that a little bit more further in this call. In contrast, if you don't have a very strict RPO, you're going to have more options, and you can start to look at potentially optimizing for cost or performance, and that's something else that we'll cover shortly. So we love 3-letter acronyms here at Microsoft in the Fast Track team. So RPO, recovery point objective, how much data the business is prepared to lose in the event of a disaster. RTO, recovery time objective, how much the business is prepared for the system to be offline in the event of a disaster. And RLO, which is one you might not hear as much compared to RPO and RTO, but that's how much of a degradation in your system performance the business is prepared to live with or accept in the event of a disaster. So I've got a little bit of an animation slide here to just try and put that in pictures, but let's go. So every so often we'll do a backup of our data or synchronize the data to another place. Now, then a disaster happens. So everything that has happened since that first backup was taken has been lost. And we call that last backup our recovery point. It'll then take some more time for us to recover our systems or fail over to another region or to do whatever we need to do to get things back up and running again. And until that point, our recovery time, our system is offline. So yeah, that's a little bit of an illustration about how that all hangs together. So reasons to consider geo-distribution, HA and DR, they're often the first reason why our customers are thinking about geographically distributing their apps, but there's other reasons to do it as well. You might be considering multi-region architectures because you're anticipating high levels of scale. You might need high levels of performance, or maybe you've got a customer base that's spread all over the world and the location or the sovereignty of the data is important. So now that we've talked a bit about the why, I'm going to hand over to John and he can talk about the how. Okay.
Thank you, Jason. Hi, everybody. I'm just going to share my slides as well. Hopefully that works. Cool. Yeah, so nice to meet you all. Thanks for joining the session. So Jason's talked a lot about why we might consider geographically distributing our solution. Now I'd like to start getting into the how. So what kinds of architectural patterns can we consider, and what kinds of technologies and features in Azure can we talk about? So we're going to talk through a few different patterns and approaches to solve different kinds of problems and for different kinds of solutions. And we'll start with one that kind of picks up where Jason left off, which is active-passive deployments. So this is, as Jason said, this is what a lot of customers think about when they think about geo-distributed architectures. So again, let's go back down to Australia and New Zealand. And Jason mentioned before that we're talking through the scenario of a hypothetical startup, Fourth Coffee, who has a single deployment of their solution. Right, this is the diagram we saw before. The solution is deployed into Australia East. So we'll represent it like this, right? We'll just have a green diamond to represent our active deployment. Now, one thing that Fourth Coffee could do if they wanted to have some level of resiliency against disasters is to add a second deployment in another region. So in this case, they might pick Australia Southeast, which we've got here as a little red box. Now, in normal operation, when everything is working as it should, all of our traffic will go from our users, wherever they are, Australia, New Zealand, doesn't matter, they will go to Australia East. All the traffic will be directed there. But what's happening behind the scenes is that we'll have some kind of secondary replication of our data to go back to Australia Southeast. That's that kind of that backup or that synchronization that Jason was talking about. So that will keep the databases or the state, the data in Australia Southeast up to date. And then, of course, if we have some kind of disaster, so a giant exclamation mark appears over half of Australia, then or we have some other event that means we have to fail over, we effectively swap, right? We get our secondary region ready to accept traffic, and then we swap the roles of those two deployments. And now all of our traffic from wherever it's coming from goes to our deployment in Australia Southeast instead of Australia East. So conceptually, it's pretty straightforward. So in this kind of architecture, we've got multiple deployments, but only one of them is active at a time. The rest, in this case we just had one, but you could have others, the rest will be passive. Now, what that word passive means is where things start to get a little bit more interesting, because we can actually think about 3 different types of passive deployments. So we can think about cold deployments. So these are where we have resources in a secondary region, a secondary deployment, but these are only deployed when we need them. They're deployed just in time in response to a situation that requires them. In order for us to do this, we need to be able to deploy the infrastructure, to configure it, and then deploy our applications to it at the point in time where we need it. So things like infrastructure as code and automation become really, really important with this kind of deployment. A second option is pilot-light passive deployments. So in this situation, we have resources that are always deployed in our secondary region, but they're deployed in some kind of minimal configuration. So we might not have the same all the same components as our primary region, or we might have them at a lower scale. And then at the point where we actually need them, when there's a disaster, when there's a failover situation, then we can scale those up, or we can do whatever we need to do to kind of light up the rest of our resources. The third option is a warm deployment, and this is where everything is deployed and ready to go in our secondary region, probably at the same level as our active region, so that we've basically got a fully redundant copy of everything sitting there waiting, ready to go. Now, Jason talked about RTOs, and that's the recovery time objective. That's how long it takes for our solution to come back online after a disaster. And this is a target that really the business needs to set. So our job as developers, as architects, is to help implement this RTO, but it's usually not to define it. So if you're getting requests from the business to help define that, I'd certainly encourage you to talk to the business about what the system represents, how critical is it, what's their level of risk tolerance, and then help them make an informed decision about that. If you have a solution that can't afford any downtime or very minimal downtime or degradation in performance or functionality, then you'd probably want to consider a warm standby pattern. So, or you could consider one of the active-active patterns we'll talk about a bit later. But if you can afford a little bit of downtime or a slightly degraded experience, then you'll probably want to look at pilot light regions. And if you've got if you're very flexible, or you've got very low requirements, or you can switch to manual operations, then potentially a cold deployment could work for you. All of these come with trade-offs. So obviously the warm deployment gives you the lowest RTO, but it comes with the highest cost. Because we're going to have resources sitting there ready to go, potentially not being used or not being used very much anyway. And so we're increasing the cost of our deployment and our solution overall. In contrast, cold standbys are usually very, very cheap because potentially we have very little, if any, resources deployed and waiting. So let's go back to the fourth coffee architecture and have a look at how this might work within that kind of architecture. So this is the diagram that Jason showed before. So if we think about adding passive deployment, then here's one way we might be able to achieve this. So you can see that we've essentially got now 2 copies of our original architecture, one in Australia East, one in Australia Southeast, but now we have this new component in there, which is Traffic Manager. So Traffic Manager is a DNS load balancer. It tells clients which server to talk to based on rules that we can tell it, that we can set. So one of the common rules that we might use, for example, is to look for unhealthy backends, unhealthy applications. And if Traffic Manager sees that the application is unhealthy, it can then route the traffic to the alternate region instead. So for example, in a Traffic Manager architecture, in an active passive architecture, we could have Traffic Manager switch to the warm or the pilot light region when it detects that the primary region is unavailable or unresponsive. Now that's all well and good for stateless components, so application servers and those kinds of things, but we have to also take account of things like databases and storage accounts and other things that hold state. And this is where things get a bit more complicated. We have to be able to get our data from our primary region to our secondary region so that we can use it. And we need to know what our RPO is so that we can make sure we're replicating that data or getting that data across at an interval that's going to reduce the data loss to a point that we're happy with and that our business is happy with. Otherwise, if we don't do this, we're going to have a completely functional application tier with none of our customers' data in the secondary region. That's not much good to anybody. So I'm going to talk about a few of the products in Azure or the services in Azure, just to give an example of how we might think about doing replication of data across regions for these. So one is Azure Storage. Blobs, tables, queues. This is one of the core services in Azure. Storage lets you do geo-replication. There's actually a few different options you've got for geo-replication with Azure Storage. And what it's important to realize here is that we target a replication time of about 15 minutes. So in other words, if you make a change in one region, we expect that that will probably be propagated to the other region within about 15 minutes. I'm saying around and about because we don't guarantee that. That's really important to know. So if you had a requirement that you had to achieve lower RPOs or you needed to guarantee that, you'd have to look at solving this in your application. You'd have to potentially have your application write to 2 different storage accounts in different regions. You can also achieve different recovery level objectives as well. So Jason mentioned these before. These are the ways in which your application might have a degraded experience, or there's some kind of compromises you make during a disaster. So for example, you might be able to consider making your secondary deployment read-only. And if you do that, Azure Storage actually has some really nice options for that. There's a storage tier called RAGRS, which potentially could be a really good option. So for a solution like Fourth Coffee, where it's predominantly a read workload, where we're mostly reading data out of a database or our storage account, that could actually be a really viable option. In other cases, it won't be. Now, of course, Azure SQL DB is one of our other big products. This is the relational database that a lot of customers use on Azure. And there's actually a few different options you've got with different RTOs and RPOs, and there's quite a few different permutations around how you can set that up. One option is active geo-replication. So this was where you have a single primary region, and then you replicate that out to multiple secondary regions. And you can actually, similar to storage, you can choose whether those secondary regions are readable or not, and that potentially can help with different scenarios too. Also, if you don't have a very high RPO requirement, then you could actually consider doing something like a restore from backup. So rather than doing geo-replication of your data, could you just take a backup, ship that backup off to a different region, and then at the point in time where you need it, you can restore that backup, and of course you'll have a higher RTO and a higher RPO, but potentially that might be okay for many solutions. And then, of course, we've got Cosmos DB, which gives us a lot of options around geo-replication. As Amanda mentioned, Cosmos DB is a fully globally distributed database, so it's got these features built in. And you actually have lots of different options for how you can achieve different RPOs, different consistency levels, and all sorts of other things. So depending on how you configure it, depending on how much you want to spend as well, then you've got different options there. Again, we're not going to get into the details of how all this works in these services, but there's a lot of really good information on our documentation about that. So when you're considering doing an active passive deployment, you really need to give a lot of consideration to the process by which you will switch to that passive region. This is called the failover process. So firstly, the first thing you need to think about, and this is harder than it sounds, is how do you detect a failure and then decide to fail over? Will this be an automatic process or will it be a manual process? Will humans be involved at all? Do you need to have health probes? So Traffic Manager, for example, will use a health probe to check your application's health. What does a health probe actually do? What is it checking? Do you need to send an alert to a human? If so, how? Is that going to wake them up at night? Is it going to be something that you actually need to have different failback options depending on if you get responses in time? And then what's the policy? How long do things need to be down for or unhealthy for before you decide to fail over? So this is actually quite a complex decision, and it really needs to be thought through ahead of time. Then you need to actually do the failover and redirect your traffic. So if you use Traffic Manager or another product, Front Door, which we'll talk about shortly, they have options for doing automatic failover. But if you've got a pilot light or certainly a cold deployment, then you might need to do that manually. So again, depending on your RTOs and what your requirements are, that might need to be automatic. It could be manual. Then you need to plan out the entire failover and the failback process. So when I think about this and when I talk to customers, what I suggest is put yourself in a really nasty situation. Imagine you've just been out drinking on a Saturday night. It's now 2 a.m. You've been woken up by this alert that you've configured to say everything is broken. What do you need to do and how do you need to do it? How do you present that information to yourself or to your team so that you can get through whatever you need to do to get your system operational again and then get back to bed? So you want to make sure you have very clear expectations, very clear documentation about all the steps that need to happen for that failover, and then make sure you keep those updated as your solution evolves. You also want to plan how you fail back. So if you've switched from your primary to your secondary region, how are you going to switch back again? Are you going to switch back again? If so, is that going to be a more managed process? Often failback is a little bit easier because you've got a little bit less pressure on you, but it's still something you need to really clearly consider. Now, putting yourself back in the position of being woken up at 2 a.m., even better than having a good Word document with all of the steps to follow is having a script that you can run that will take care of all of those steps for you. Or even better than that is having that script automatically run on your behalf if you need that level of RTO. So if you've got a very low RTO, anything less than an hour is kind of what we suggest here, you absolutely have to have a fully automated process. Inside Azure, because of course we're running a planet scale solution, we have everything automated. All of our failover processes and everything is all automated. But depending on your requirements, you don't want to over-engineer this if you don't need it. So again, be really clear about what your RTO and RPO are so that you can design the right kind of architecture. And then the last thing I want to mention on this is that you really need to test and rehearse. So you need to make sure you've tried the entire failover process and you've made sure that everything actually works once you've completed that failover and then the failback. All right, so that's the first pattern I want to talk about, which is that active-passive pattern. Now I want to shift gears and talk about another pattern that we can use for geo-distributed applications. So let's say that we've got our application, our Fourth Coffee application that's hosted in Australia East. We'll take our passive deployment out of the picture again. We'll pretend that doesn't happen. And we've got a client accessing that from somewhere in Europe. This is in Spain. So the first thing that happens when that client tries to access our fourthcoffee.com website or API is that their server or their client will try to resolve that hostname, fourthcoffee.com, to an IP address. It will then use internet protocols to route traffic across the internet. And this is what a path might look like. I've made this up. This is completely hypothetical. But basically, internet routing protocols will send the traffic via these red interconnection nodes. These are all over the planet. There's lots of them all around the place. And so, of course, the traffic will flow through those nodes, ultimately ending up at our server in Australia East. Now, there's a few things to be aware of here. One is that there will occasionally be hiccups. The more links we have in this chain, the more nodes there are, each of those nodes is a potential point of failure. So the more links we have, the more likely it is that something is going to go awry, and then there's going to have to be some routing around those points. So again, that might not be a huge problem, but it's something to be aware of. The second thing to be aware of is that the handshake speed starts to matter here as well. So if we're going across the planet, and I've picked kind of the worst case scenario here with Europe to Australia, just the speed of light and the amount of time it takes for data to get back and forward across that kind of network means that even just to establish that connection is going to take around 700 milliseconds. That doesn't sound like a lot until you think about this from the user's perspective, where they might be making multiple connections, or there might be a whole lot of activity going on. So 700 milliseconds is actually a really long time on the internet. But as Jason mentioned, we have a global network with all this dedicated cabling and infrastructure all around the place. So surely there's something better we can do. I saw there was a question in the chat before about what are those blue points on the, or blue squares on the map. So those are Azure data centers or edge nodes. So we have data centers, as Jason mentioned, those are in our regions. In addition to those data centers and regions, we also have these things called points of presence or edge nodes. These are the places that traffic can go from the internet into our network. And we can make a really good use out of this. So first, what we could do is we could have all of the edge nodes across all of Azure broadcast the same IP address. This means that any client who tries to access our site using its IP address will be routed across the internet to their closest edge node. This is called Anycast IP. So if we zoom into what happens to our client in Spain, well, as I've said, clients are going to be connected to their closest edge node. And you'll see there are 3 edge nodes in Spain. So what we can look at is that user will be routed to the closest edge node, or the one that's got the least cost for them to connect to, the least cost in terms of time. So they'll be routed to, for example, this edge node down here, which is the one that's geographically closest to them. Now, this is making use of a technology called Azure Front Door. So the client will make a request through Front Door. And importantly, this is where their TCP connection and their TLS connection terminates. So what this means in real terms is that the handshaking we talked about before, which previously took 700 milliseconds or so to go across the planet, is now happening just down the road potentially. And that means that it's gone from that 600, 700 millisecond latency, maybe to about 30, 40, 50 milliseconds, which is a huge difference. That Front Door edge node then has a connection all the way back to the server in Australia. And that connection is held open for a much longer period of time, generally about 30 minutes. So it's not taking the cost of that establishing that connection over and over again. It can be reused without having to repeatedly handshake. This whole process is called split TCP. So we're splitting the TCP into 2, right? The TCP connection has a connection from our client to an edge node, from our edge node back to our server in Australia. And so the combination of these 2 approaches, Anycast IP and split TCP, can be used to really efficiently geographically route traffic to our application using the Microsoft backbone. And it's usable with any number of active regions. So if you've got an application that's just hosted in one region, this works really nicely. If you've got applications that are hosted in multiple regions, like we'll talk about shortly, it also works really nicely. So this can be a really good way of helping to improve the performance of an application, even if you've just got a single region, if you've got users coming from all over the world. And if we look at this in terms of our original application architecture, this is where we started from originally. All we're doing here is adding Front Door in front of our single page app and in front of our API. And our client will now connect to Front Door instead of connecting directly to our servers. Just by doing that, we start to get all the benefits of this geographically distributed traffic. And that happens, as I said, even with just a single region deployment. It's not adding any resiliency to our deployment. We're not protecting ourselves against disasters here, but we are improving the performance of our solution. Now, not only that, but because Front Door is in the picture now, it's acting as what we call a layer 7 reverse proxy. What that means is that it can do a whole lot of stuff on our application's behalf. So things that our application might have otherwise done can now be done by Front Door instead. So firstly, who likes dealing with HTTPS certificates? It's a nightmare, right? And if you have to rotate certificates and change them and update them, that's really annoying. So if you can offload that to a service like Front Door, then that's even better. We can also put a web application firewall at all of those points as well. So we'll be able to screen the incoming traffic from our users for threats before it even starts going to the region in which our application is hosted. We'll block this well before it even enters our network. And we can perform complex routing logic. So we can rewrite requests. We can send them to different places depending on who's sending them or what's happening. And we can do caching. And in fact, this is such an important thing that I've actually broken this out into its own pattern. So let's consider our example before, where we've got our user in Spain who's accessing our website. And they're doing that through this local front door point of presence, like we talked about. Now, when front door goes off to our server in Australia and gets back a response, we can tell it to keep a copy of that response in its cache. And it can do that and then return that response back to the user. What that means is that the next time somebody else asks that same front door point of presence for the same content, then front door can just go straight to that cache, pull that document back and send it to the user. So this is going to also be a huge performance boost, especially for globally distributed applications, and it's going to reduce the load on our application server significantly. If we design our caching strategy really well, then we can make sure that the majority of our requests potentially could be served from these caches instead of going back to our application server. That reduces the cost of running the infrastructure, it makes everything more resilient, and it also means that we have much higher performance for our users. Now, there are actually two different services in Azure that can help with this pattern. The first is Azure CDN. This is really optimized for static workloads, so things like marketing websites, company homepages, image files, those kinds of things. And then the second is Azure Front Door, which we already spoke about. That Front Door is optimized for dynamic workloads, so APIs and server-generated applications, and things that return different responses for every request. But it also has a cache, right? So like CDN, it has a cache as well. When you use these services, you have a lot of control over how that caching actually works. You can specify how long items should be stored in the cache for. You can do this using standard HTTP response headers, so your application can be in charge of this if you want to. Or if you have an application that you don't want to modify to deal with this, then you can override those in a central location. You can actually specify that within the configuration of Azure CDN or Front Door. You can even have applications manually remove items from the cache if they need to quickly get rid of things. So if you've got items that will typically never change, but occasionally they will, you could potentially say, well, keep this in the cache for a very long time. And then if you do see a change, your application can put out a request to CDN or Front Door saying, please get rid of the copy you've got and here's a new version. Now, when we think about what kinds of things make sense to cache, there are some really good candidates for different workloads. So firstly, any media file, so things like images, videos, PDF files, other documents, those are really obvious candidates. Secondly, any static web apps. So if you've got a single page JavaScript application or even just JavaScript files or CSS, HTML, those kinds of things make a lot of sense to cache as well. But we can also consider whether we can do things like caching API responses. So for example, for the fourth coffee scenario, if we've got a cafe review API, then potentially the responses that API returns might be cacheable, right? It might be a little bit expensive for us to go to our database and constantly reestablish which review should be returned for a given response. But again, if we design our API requests and URLs and so forth to be cacheable, then potentially the response that's returned could actually be cached for some period of time and reused for other requests. And of course, speaking of fourth coffee, they haven't had to do anything special to include this caching capability in their architecture. If they're using Front Door, then they just have to turn on the caching feature. Okay, so I want to shift gears now. We've talked about active passive deployments. We've talked about kind of globally distributed applications that can make use of Front Door and CDN for routing traffic back to the origin and for caching them. Now we're going to talk about another approach. So let's go back to our original architecture before we put Front Door into it, right? And let's say that we've followed best practice that you hopefully have heard about from everybody at Microsoft constantly, which is to use infrastructure as code to templatize and script out all of your deployments. What that means is that even if today we just have a deployment in Australia East, we can easily rerun that template all over the world. We can deploy that same template out to multiple Azure regions. And so if our fourth coffee review empire starts to expand, then we can quickly deploy new instances of our solution where they're needed. Each of these is called a stamp. Now, each one will run independently of each other. So they have their own data stores. They potentially have their own domain names and their own way of being accessed, but they are instances of the same solution. So they can be developed and deployed and managed together. You can have the same DevOps pipeline pushing out your updates to all of them. You have one code base that you're using for all of these different solutions. Now, it's important to remember that from a deployment point of view, each stamp is independent of the other. So that means it has its own database. So different users of our application potentially might need to be routed to different stamps depending on where their data resides. This is a really good thing if you're concerned about data sovereignty. So if you need to make sure that your data lives within particular geographic regions, but you still want to have your solution run across the entire world, then a deployment stamp model can be a really good way of achieving that. But we need to ensure that our users are routed to the stamp that has their data on it. So let's go back to our example before. We've got our user in Spain. Their database might be stored within a database in the EU stamp, potentially. So that's where all of their requests need to go. But it's important that we remember that if they jump on a plane, which I know nobody's jumping on planes now, but if they did, and they went for a nice holiday down to Perth, then any further requests that they make to their application need to go all the way back to that EU stamp as well. Now, of course, we can route that through front door. We can try and improve the performance of how that works. But ultimately, even though there might be a stamp that is geographically closer to where they are physically at that time, it's no help sending their requests to it because their data won't be available there. This may or may not be an issue for us, right? So if we can assume that users are typically going to be where their data is or close by, then potentially this isn't a concern, but it's something to be aware of. So essentially, stamps are a way of partitioning our entire solution, our entire workload. Each stamp runs independently of each other. They also act as fault domains. What this means is that if you have a problem in one stamp, so for example, there's an issue with Azure resources in one particular region, that won't affect another region. It's still not necessarily good. It's not what we want in that region, but at least the blast radius is contained. They also act as upgrade domains. So if we decide to update just one of our stamps, we can do that, or we can roll our updates across our stamps gradually to verify that they're safe. We can also potentially make use of this kind of pattern, this deployment stamp pattern, without having to significantly change our architecture. So we don't necessarily have to completely throw away everything we've done. We're essentially taking what we've already done and then just putting multiple copies of it around. We can also make sure that we're putting these stamps geographically close to our users, which can help with performance. And we can use this as a way to meet data sovereignty requirements as well. Also, if we've got a multi-tenant architecture, so for example, if we're running a software as a service kind of scenario or some other ISV, then we might be able to look at using stamps to support different types of multi-tenant architectures. So some customers might share a stamp, others might have their own dedicated stamps. Now, there are some really important challenges and things to be aware of with this. Firstly, automation is always important, as I hopefully have made clear already, but it's especially important when you do something like stamps, because you need to make sure that everything is templatized, everything is scripted for all of your deployments and all of your maintenance. You don't want things to get out of sync across all of your stamps. Secondly, if you need to do queries across multiple stamps, then you can do that, but it's potentially more challenging. So, for example, if you have a stamp-based architecture where you've got systems taking orders for products, you'll probably want to have some consolidated view of all of the orders across your entire solution. But of course, all of these stamps are independent, so you're going to have to work out how you do that. One approach might be to have all of those stamps publish their data into a central, globally central data warehouse, for example. And then we also need to consider how we're going to handle disaster recovery. So a single stamp is a failure boundary, right? So it basically means that we might need to consider using this in conjunction with the active passive pattern. And one of the benefits, if you've got one of those multi-tenant architectures we talked about, one of the benefits of the stamp approach is that potentially some customers might have requirements that have very high RTOs and RPOs, so they can be put on a stamp that might have a different kind of DR strategy than other customers. And fourth, as we've talked about, every stamp has a subset of the data. So this means that you need to route requests to the right stamp in order to make sure that the data is being served correctly. And this can be tricky, right? So if we've got different domain names per stamp, then that's the simplest approach. But then your users need to be made aware of how which stamp to talk to. So that's where the last pattern comes in. this is called the Geodes pattern. So in this pattern, we have multiple deployments. In this case, I've simplified our architecture just to show the two key pieces I want to talk about. So a function app and a Cosmos DB instance in each region. Each one of these is called a geode. And that name, by the way, comes from geographic nodes or geodes. Now, the key thing that distinguishes this from a stamp architecture is that each geode holds a copy of all of the data. So this relies on having some sort of backplane that's keeping all of that data in sync across all of these different databases. Cosmos DB, very conveniently, provides this feature in the form of multi-master writes. So I think Amanda mentioned that before. Most databases don't have this feature. So if you're going to implement this kind of pattern, you need to make sure you're using the right kinds of technologies to support it. And really, you need to be using something like Cosmos DB to be able to have that replication backplane and the multi-master writes capabilities across all of those different instances. But what that means is if we can meet that requirement, then by having all of our data synchronized all the way across the globe, it means that any request can be served from any geode. And so we can route requests to the closest geode to the client by using something like Front Door or Traffic Manager's performance-based routing mode. This basically means when a client requests a connection, we'll send them to the closest one to them rather than the one that might be further away. So going back to our example earlier, if we've got a user in Spain, when they're at home, as before, their requests will be directed to that EU Geodes function app. And if they hop on a plane and go back down to Perth and go through quarantine again, then their requests will be served by the Australian geode this time because they are now closer to Australia. And so the performance of this application is potentially even better than before. This kind of architecture gives some really big benefits. And when I talk to customers about this, often this gets them very excited, right? Because this becomes a highly resilient platform. Even if a single geode or even if multiple geodes are unavailable, all of the others in the network can take over for them. It's also very performant because we can spread our requests across all these geodes. And because we can serve requests from a location that's geographically quite close to where the user is, we can then add and remove geodes as required to cope with different changing demands across regions. Bringing a new geode online really just means we have to provision our resources and then wait for that data replication to take place across the Microsoft backbone. Now, as I said, this sounds like a dream come true, but there are some very important things to be aware of. So firstly, really this pattern needs to be built on top of fully cloud native technology. So things like Front Door and Cosmos DB. And because of the fact that this is using active geo replication and multiple write regions, we also need to use or to accept the idea of eventual consistency. So in other words, some of the data that we update in one region may not be replicated in real time out to other regions. This doesn't sound like a good thing, but in many cases, this is actually okay, as long as you design and plan for this up front. And because of these two constraints, really, unlike a deployment stamp model, a geode architecture really needs to be designed up front. You can't just adapt an existing solution to work with within a geode model. You really need to design it up front with all of these constraints in mind. And of course, I'm going to harp on about it again. Like everything we've talked about today, automation is absolutely critical, both for the deployment of the geodes and the management of the geodes. And I should mention that inside Azure, many of our services actually work according to this kind of architecture, right? So Azure AD is a globally distributed service that runs on top of an architecture very similar to this. Azure Resource Manager works a similar kind of way, Skype, and a bunch of other solutions too. Now, because this involves deploying resources across many different regions, potentially many different regions, managing the cost could potentially be a challenge. So it's worth considering the use of serverless components and those with consumption-based pricing models. So for example, Azure Functions could be used as a compute layer. And if you use this in the consumption tier, you don't pay for a given Geodes function app unless it's actually doing something, unless it's receiving requests or processing something. We've already talked about front door, which is used for that geographical and performance routing, and also to get all of those benefits we previously talked about split TCP and the routing traffic across our backbone. And of course, Cosmos DB is giving us a fully cloud-native database with active geo-replication, multi-master rights, and it also has a change feed, which can be a really nice way of being able to do event-driven architectures on top of a geode kind of pattern. It's also getting a serverless pricing tier, which is very convenient if you're thinking about this kind of architecture as well. So, in summary, hopefully this session has left you with a lot of different ideas. Probably the key thing we want to get across today is that global distribution can imply many different things. Often it's thought about in terms of high availability and disaster recovery, but there are lots of other reasons why you might want to do global distribution as well, to support data sovereignty, to support higher performance, or to allow for scaling across users who are going to be in multiple countries or different geographic regions. In general, it's much easier to geographically distribute compute than it is to geographically distribute data. State is the thing that needs to be really thought through well. And so if you're doing high availability or disaster recovery planning, you really need to think through things like those RPOs to be able to understand what kind of replication or backup processes you need to have, what kind of frequency you need to do those on, and make sure those are going to fit your requirements, both in terms of meeting those RPOs, but also in terms of your cost and budget availability. And then when you start looking at at all of these different factors, so we've talked about consistency, having data in sync across different parts of of your solution or across the world, availability, so being able to access your solution at a very high rate, so having a high uptime, performance, so how quickly is your application responding, especially to geographically distributed requests, and cost. All of those things need to be carefully traded off. And hopefully, the other thing that's really been clear here is that you need to have clear requirements to be able to architect these kinds of solutions well. You need to know what you want to achieve, but you also need to know what constraints you're operating under from your business stakeholders or from your customers. So, for example, if you're only concerned about disaster recovery and high availability, then maybe a active-passive configuration is sufficient, or potentially even just zone redundancy is sufficient if you can use that. For many of our customers now, we're actually suggesting that now that availability zones are available in Australia East, for many solutions, availability zones are probably all you need to cover off most customers' risks that they're actually concerned about. We don't want to get too caught up in kind of disaster movie scenarios and thinking about, Godzilla coming and ripping out all three availability zones. Really, what we want to think about is realistically, what are the kinds of things we're trying to protect against? What are those requirements, and then how can we meet them? If you've got, on the other hand, if you've got a truly globally distributed user base, or your application is scaling out to go across the whole world, you'll want to consider things like edge termination using front door, edge caching using front door or CDN, deployment stamps, and geodes. And also remember that different parts of your solution might have different requirements for this as well. You can mix and match these, right? So you could have, for example, some components of your solution that are completely built on a geo architecture, other components that might be stamp-based because they have sensitive customer data that has to have data sovereignty concerns, for example. And of course, I would say that these architectures can get complicated, as you can probably see. So remember that you've got access to a whole ecosystem of Microsoft partners who can help to provide guidance and feedback on these kinds of architectures. And then, of course, as Jason said, the Fast Track for Azure team, my team, is also happy to help for eligible projects, and you can contact your Microsoft account team if you'd like to talk about that. So with that, I will take some questions if there are any.
Brilliant. Thank you for the amazing session as always, John. So we do have a couple of questions from the chat. So this one is a bit of a complex question. So for PaaS services like app service and functions, who actually syncs that code and configuration so that during a disaster, we can switch to the backup one? And is this maintained automatically by Azure as part of our SLA? Or does the customer still have to configure and change different workloads to make sure it's still up? And how is this backup performed?
Okay, right. There's a bit in there. Specifically for Azure App Service and Azure Functions, those are region-specific services, right? So when you deploy one of those resources, you're deploying that into a specific region. So there is no built-in concept of geo-redundancy in those services. So if you've got the requirement to do have a kind of a disaster recovery, like active passive kind of deployment configuration, you will need to manage that yourself. So the way that we typically would guide customers to do that would be to have their infrastructure as code deploy the exact same infrastructure into two regions, and then have their DevOps pipelines, so their Azure pipelines or TeamCity, whatever it is, their CI/CD tooling, deploy the application onto those two instances. So you would need to take responsibility for those particular services. Now, there are other services where we do that for you, but for those particular ones, those are region-specific services.
Brilliant. Now, often in our architectures, we'll use things like Traffic Manager and Front Door to help with our regional and geo disaster redundancy. So what actually happens when the region that Traffic Manager sits in is encountering a disaster?
Yeah, so that's a really good question. So Traffic Manager and Front Door and a handful of other services are a bit special in Azure in that we don't actually run them in a single region. We run some of those services across all Azure regions, or sometimes across all Azure regions and also all of our edge nodes. So Traffic Manager is one of them. If you've ever deployed Traffic Manager using an ARM template or through the portal, if you look at the region that you're setting, it's actually not a region, it says global. And the reason for that is that when you deploy one of those resources, you're actually deploying it across our entire network. So most resources don't work that way, but there's a handful that do, and Front Door and Traffic Manager are two that do. So what that means is that these are highly resilient solutions. So even if we have a region-wide outage or even a country-wide outage, the way that everything will get routed is they'll just get sent to another Traffic Manager or Front Door entry point somewhere else. And that's not to say that we don't have outages, right? So you might have heard that we did have Front Door outages, I think twice this year. All I'll say about that is that when that happens, you have to believe the fire alarms go off at Microsoft. We rely heavily on Front Door and Traffic Manager for our own solutions. So we have a really strong interest in making sure that we get those situations resolved as quickly as possible. But for smaller outages, for region-wide outages or failed deployments in a region, you wouldn't even notice it's happening because we just route around those regions because they're globally distributed services.
Awesome. We've also gotten quite a few questions on geodes. So the first question is, should we clone all dependencies that a resource required in each geode, or should we put this randomly across geodes? And is this mandatory / why would we put it all in one?
Well, yeah, okay, that's a complicated question. So I'm going to give you an annoying answer from Microsoft, which is it depends. The basic idea with this would be, if you're following the geode pattern as written, and I helped to write it, so I should know this, then you'll basically have to deploy everything into all geodes, right? That's kind of what the pattern is. That's where you get some of those benefits around the extra resiliency and those kinds of things, is by having everything everywhere. That will mean that you can't use some services, right? There are some things that just don't make sense in that kind of architecture, and that's where I was saying you need to plan this up front. So yeah, so if you're not looking to strictly follow the pattern, if you just kind of want to loosely follow it or kind of do a hybrid pattern, then yeah, absolutely, you could look at having, for example, some resources deployed everywhere, and then some resources deployed just in some locations. So a good example of this might be, I'm making this up on the fly, so apologies if this is if this isn't quite right, but something like Azure Media Services, right? So it might not make sense to have an instance of Azure Media Services in every single region that you've got a geode in, if you've got an application that needs to do live streaming or something like that. But instead, you might have kind of regional hubs for those. So you might have geodes throughout the world, but then you have maybe 4 or 5 regional hubs for something like Azure Media Services. And then geodes would know which of those regional hubs they should talk to or direct users to for their particular location. So yeah, it depends a bit on the architecture there, and that's something we'd probably need to get into over a whiteboard.
Yep, fair enough. And as a disclaimer to everyone in the audience as well, if you do have further questions or have further whiteboarding requirements and case studies, feel free to reach out to anyone on the Microsoft account team, such as myself, Shuri, anyone you've interacted with at Microsoft. And then if necessary, we can engage John and the rest of the Fast Track team. So the other question around Geodes is, does this apply to all Azure services, or is it a better fit for a certain subset? Is it only compatible with a list, and is this list available?
Yeah, so I mean, this is an architectural pattern, right? So it's not a product. It's not something that we have a list of, here's the services that are compatible, here's the services that aren't. As I mentioned, in order to kind of achieve that pattern, in order to achieve the benefits of that pattern, you need to make sure that you are following some rules. And so the big ones are having replication of data, right? That is the biggest one by far. As we've talked about through the presentation, data is the hard thing to deal with in geographically distributed applications. So you need to have a database technology that can meet that requirement. I would say that things like storage accounts and Azure SQL would be much more challenging to get working in a Geode architecture than something like Cosmos DB. That's not to say that you couldn't use those inside an architecture. It's just that you would need to make sure that you are very carefully designing how your data flows through those systems. So for example, if you're deploying a function app has to have a storage account, right? So I'm not saying don't deploy any storage accounts anywhere. What I'm saying is you don't want those storage accounts to be the primary source of the data that's being replicated everywhere. So you can use a bunch of different services together to achieve those kinds of architectures. But yeah, and then if we talk about the consumption-based services, there's nothing inherently in the Geode pattern that says you have to use consumption-based pricing services or consumption pricing-based services. But in reality, if you're using Geodes to deploy 10, 15, 30, 100 instances of your solution around the world, probably you don't want to be paying huge amounts of money for all of them. And so consumption-based services can be a good fit for that kind of architecture. But again, it depends.
Fair enough. Our next question. So this is related specifically to Azure Service Bus. So in the context of Service Bus for zone redundancy, how do we ensure that a message is only picked up and processed once it's available on multiple queues/zones with subscribers in each zone?
Yeah, so the way that Service Bus does zone redundancy is that I think Jason showed the kind of the synchronization backplane there. So what's happening there is when we accept a request or accept a message into Service Bus, regardless of whether it's zone redundant or not, we will make sure that we have what we call a quorum of replicas accept that request. So we will not return a response back to the sender of that message saying we've accepted it until at least 3 separate physical nodes or virtual nodes have also accepted that request. So if we're doing this across availability zones, we make sure that we're using different physical replicas in at least 2 zones. So what that basically means is that from the sender's point of view, by the time they've got a response to say yes, this has been received, we then have that data in at least 2 different zones. The data the information about the messages is constantly being synchronized between those zones, and we can do that because they're relatively close together. We can do that synchronously. So within availability zone regions, all of that kind of zone redundant replication happens synchronously. And so from the client's point of view, they don't need to be aware of the fact that this is even happening, right? You don't need to write your code to be able to know that you're talking to zone A versus zone B. All you're doing is saying, I want to connect to the service bus and receive a message. And then behind the scenes, the service bus infrastructure will make sure that it delivers you a message from one of those zones.
Great, so we actually don't have to worry about double processing in your zone redundant context at all.
In a zone redundant context, you don't. In a geo-redundant context, that's a whole different story. That could easily be a 1-hour talk. In fact, one of my colleagues, Dan, actually did a 1-hour talk on that just last week or the week before. And I might even see if I can put a link somewhere to that, because that was a really, really good session talking about if zone redundancy isn't enough for you, here's how you get the next layer of geo-redundancy. Spoiler, it's complicated.
That would be great. If we can get the link approved, we may put that in the LinkedIn group after the session as well.
Awesome.
So, John, I'm interested to hear if you have an eloquent answer to this question, because I certainly can't say it without laughing. So why are all services in Azure not treated globally like Traffic Manager and Front Door? Why do we even need to have, say, your function app located to Australia East instead of just being on a global presence?
So this is the cloud equivalent of saying, why don't they make the airplane out of the black box material, right? Basically, let me see if I can form an answer to this. So if you look at the list of services that are in that category where they're globally redundant or deployed across the entire of Azure's network, there's the ones I can think of are Azure DNS, Traffic Manager, Front Door. I'm probably missing a few, but those are three key ones. If you think about those are all network related, right? Those are all services that run at the edge of our network in some form. And they're also got extremely high resiliency requirements. So what that means is that we can, when we're thinking about deploying this, we have to deploy this everywhere anyway for this to actually make sense, for that service to even be available in that region. So for networking services, that's such a fundamental kind of fabric layer service that we just have to have that in every location anyway. With other services, so anything more complex than kind of those basic networking services, there are a lot of physical infrastructure components required to support them. So if you think about, let's just take app service. App service behind the scenes is actually a whole bunch of virtual machines, as well as some databases, as well as some storage accounts, as well as a bunch of other things. As we've talked about through the presentation, if you want to deal with geographically distributing a solution like that, then you need to be very careful about how you manage data. And you're going to be making compromises by doing that, right? You're going to be compromising cost, you're going to be compromising performance, throughput, all sorts of other things. So even if hypothetically we were to somehow get app service running everywhere, to synchronize all that data would then compromise the service to such a point that it wouldn't make sense. So that's why we're saying if you don't need it for those kinds of services, if we don't need to build it in, or bake it into those kind of services at the service layer, we'll help our customers to architect that at their application tier, and that's exactly what this kind of architecture talk is about. I'm not 100% sure that I answered the question there, but that's the best I've got on short notice.
No, that was a great answer. So we don't have any more questions. Let me go through the closing logistics, and if there are any questions we get in the meantime, I'll throw them at you at the end, John.
Yeah, absolutely.
So a reminder that, look, we do have these sessions regularly. We do very much value your feedback as the audience. If there are any kinds of feedbacks, like you would like to see more demos, or there are certain topics or speakers you would like to hear from, please reach out and let us know. This is season 2, so we've very much taken on the considerations of season 1, and we will eventually start planning for a season 3 when the odd 10 sessions for season 2 are over. So any feedback you have would be much appreciated. If you have any further questions as well, as iterated before, feel free to reach out to any Microsoft reps or myself, Oshri. Our email inboxes are always open, though that's a dangerous thing to say. Or you can just join our LinkedIn group and reach out via that means, and that's also where you'll get access to our recordings. So it doesn't look like any questions have flowed through in the meantime. So thank you so much, everyone, for your time. And thank you to Jason and John for the incredible presentations, as always. We will see you next week for how we run containers on PaaS services like Azure App Services. But until now, if you're in Melbourne, enjoy the long weekend or enjoy your Friday elsewise.
Thanks, everyone.
Thanks all.